So good morning everyone. We are the group 10. My name is Decadet Soner, together with my group mates, Decadet Tabia, Decadet Chopia, and Decadet Omako. So our topic is manual radar plotting. So the course outcomes of this topic is manual radar plotting, the completing a radar plot, course alteration, basics, and spread alteration. So the learning outcomes for these topics at the end of the session, the students shall be able to understand and perform manual radar plotting. The importance of the topic is radar plotting is an alternative for ARPA, and thus it will be handy when ARPA is not working. With radar plotting, we'll be given all the information that ARPA can give us, such as CPA, TCPA, course, and speed of a target. So the plotting process. So the first in the plotting process is detection. Detection is recognition of the presence of the target. Second is selection, choosing of target requiring closer observation. And tracking. Third is tracking, the process of observing changes in target position. And then lastly, plotting, the whole process of detection, selection, tracking, calculation of target's parameter. So we have to recap the ERM triangle. So the E to R, or the on-ship's true course, as you can see in the picture, is the true course, and the E to M is the true course and speed of a target, and then the RM, or the relative motion of target. In vector is shown the direction and magnitude, or the speed. So it's the same as the last. It's just a recap. That triangles, sides, and labels. So as you can see, from E, or our ship position, from to the R, or our own ship true course and true speed, and E to the M is the contact, true course, and true speed, and R to M is the relative motion. So relative motion will be discussed by Decade Tabia.
Thank you, Cadet Swanner. So for this slide, we have relative motion. So what is meant by relative motion? It is the resultant of two actual motions. But let us break this down further. The word motion implies direction, speed, and distance. Relative motion then would imply relative direction, relative speed, and relative distance, which are defined as follows. Relative direction is the apparent direction of one object's movement with reference to another. Relative speed is the speed which one object moves with respect to another. Relative distance is the distance one object moves with respect to another. These three definitions then collectively make up relative motion. If the object is a ship at sea, this motion is defined in terms of true course and speed. But if the same ship's motion is observed by another ship, this is also in motion. The motion of each ship is relative to each other. So this explains relative motion when we observe two ships that have different directions, speeds, and distances. We'll begin with the vector triangle. As is the case with all triangles, this one has three sides. Sides ER, or R, VR, represents the true course or direction, the speed or length of ER vessel. Side EM represents the true course and speed of the other, or them's vessel. Side RM represents the relative motion vector, the direction and speed of the other vessel's apparent movement. Relative motion. We have the following terminologies. CPA, closest point of approach. If the line of relative motion is extended, The CPA is the shortest distance from that line to the center of the plotting sheet, where our own ship is located. If the CPA is 0 nautical miles, we are on a collision course with another vessel. RML is the relative motion line. New RML is new relative motion line, which is derived as time moves forward. As our m speed of the relative motion line, length of r to m, drm, direction of relative motion, or the direction of r to m. The point of execution, or mx, is the position of the other ship on RML at planned time 2 of evasive action. Radar plotting used to be referred as rapid radar plotting, with an emphasis on rapid. In order to make the procedure quick and mathematically painless, contacts are usually observed at intervals of 6 minutes, 12 minutes, or 15 minutes. Calculating speeds and/or distances is extremely easy at these intervals. For example, the table shows the distances traveled in 6-minute, 12-minute intervals at a speed of 15 knots. So 15 knots in 60 minutes is 1.5 miles traveled in 6 minutes and 3.0 miles traveled in 12 minutes. We'll work a standard 6-minute plot step by step. Your ship is on course at 345 degrees true with a speed of 15 knots, and you note the following radar contact: that at 8:30 or 8:08:30, the contact bears 329 degrees at a range of 9.0 miles, and after 6 minutes, at 0836, the same contact bears 326 degrees at a range of 6.0 miles.
So, this is a example of manual radar plotting. So, the first question is, what will be the CPA? What is the contact's relative speed? What is the contact's true speed? And when the range to the contact drops to 4.5 miles, you want to change course, contact passing you on your port side with a new CPA of 2 miles. So, what is your ship's new course? So the step 1 is, notice that the plot is a 6-minute plot. So speeds, distances, and time will be based on a factor of 1 of 10. So using a maneuvering board that is displayed here in the right side, a radar transfer plotting sheet. So draw a line from the center of our ship in the direction the vessel is heading. So for example, the heading of our vessel is 345 degrees. Step 2. Plot the first contact using the 1 of 1 scale. So the 10 concentric circles on a maneuvering board each represent 1 mile in length at a bearing of 329 degrees and a range of 9 miles. Step 3 is locate the E on the plot. Set dividers for the distance our vessel will travel in the interval of the plot. In case 6 minutes at a speed of 50 knots is 1.5 miles if you calculate it. Parallel to the course line, which is our heading, which is 345 degrees, over to R and draw it in backwards away from R. So remember, the course is from E to R. So that is the course E to R. Step 4. Locate M, which is the bearing 326 degrees at a range of 6.0 miles at 0836. Now, it is possible to finish the triangle and solve for the other vessel's course and speed by connecting E to M. So this is the triangle, which is the ERM. Next one, the fifth step is draw a line from R to M and pass the center of the maneuvering board. This is the line of the relative motion, which is the RML, the distance from the center of the plot, which is our vessel, to the closest point of approach. On the RML is the CPA, or the closest point of approach. So in this case, the CPA is about 1 mile. Measure the length of R to M. To find the contact's relative speed, here it is approximately 30 knots. So the sixth step is, according to the problem, when the range to contact drops to 4.5 miles, we are to change our course so that the contact will pass on our port side with a CPA of 2 miles. The next step would be is to mark on the RML the point at which the contact reaches a range of 4.5 miles from us at the center. Label this point MX. So from MX, draw a line tangent to the 2 miles circle when we change course. So this will be the NRML, which is the new line of relative motion.
Parallel the NRML from MX to M, not to E, not to R, to M. Draw the parallel line away from M. Next slide. Step 7.2. We are going to change our course but maintain our speed. Place one leg of the dividers on a E and place the other leg on R. Swing the dividers so that the R leg, remember E never moves, crosses the NRML level. The point of intersection are R1. The direction from E to R1 is our vessel's new course. That's in this case that new course is approximately 0.12 degrees. Next slide. Manual plotting. In connection to radar means to mark one or more echoes within a specific time interval and thus decide the target's movement in relation to ownership. Next slide. Source of errors in manual plotting. First is the bearing error, distance error, error in timing between plots, error in speed, gyro error, relative speed, maneuvering of own vessel, unstable steering, yawning, etc. Bearing error. The usual method of deciding whether a collision danger is taking several bearings. This is time consuming and it requires that many bearings have to be taken. A dangerous situation can quickly emerge by taking a few inaccurate bearings from a comparatively long distance and then forgetting the target if the CPA is considered large enough. Error in distance measurement. An error in distance measurement as in bearing error can produce grave result when judging the traffic situation. Error in traffic situation. Error in timing. A timing error between two plots will result in calculation of incorrect target's course, speed, and time to CPA. Error in speed. An error on speed causes incorrect calculation in the same manners as error timing. However, we must remember that in all plotting where we wish a picture of aspect on vessel speed through the water must be utilized. Never make correction due to current or drift. In connection with plotting, speed through water should be used. Gyro error. Make it a habit to always correct the gyro for known gyro error target with low speed. Factors that affect manual plotting. Unstable steering, maneuvering on ship, the technical exactness of the equipment, rough weather condition, target relative speed, the navigator's experience, and lack of plotting practice. Next slide. This is our topic.